All right, Math 10s, our last unit to go, trigonometry. This week we're going to do lessons 1 and 2. Next week we do lessons 3 and 4, and then we are finished, okay? Because we're in a pandemic, we're not going to do the last 3 lessons, okay? Let's look at the first lesson. It's called Trigonometry Foundations, labeling triangles in relation to the given angle. The given angle, or we can call that the given angle is called the reference angle, okay? And we'll look at that in detail down below. It says the sides of a right angle triangle can be labeled in relation to a specific angle, the reference angle, the given angle. The reference angle is never the right angle. In trigonometry, the 3 labels that we give for sides of a triangle are opposite, adjacent, and hypotenuse, okay? Opposite, adjacent, and hypotenuse. So if we have a look down below, it says in the triangles, circle the reference angle. So let's start by circling our reference angle. I'm going to circle the top left and the bottom right angles. Those are our reference angles. They are labeled as such, okay? The reference angle, in this case, they are labeled as theta, okay? Theta is a Greek letter in the Greek alphabet, okay? And we often use Greek symbols for angle variables. Okay, we could use X or Y, but it's a variable. Okay, just like X or Y, but we usually use or often use the Greek letters alpha, theta, beta. You'll see those used in trigonometry. Okay, so we've circled the reference angles, good. Then it says label the sides of the triangles in relation to the given angle as opposite, adjacent, and hypotenuse. So I know you've done Pythagorean relationship back in probably grade 9 and possibly grade 8, and we know that the side across from the right angle is called the hypotenuse. Okay, so there's our hypotenuse, and that's the same as this triangle here because it's the same exact triangle with a different reference angle. Notice the reference angle is up at the top, and here the reference angle is down at the bottom right. But the hypotenuse can never change. The most important part probably of trig, and if students don't understand trig, it's often because of the following. So pay close attention to this. The sides opposite and adjacent will change depending on the reference angle. And the reference angle is what I call it in classes. I say, where are we standing in the triangle? So in the first triangle, let's call this number 1 and let's call this number 2. In triangle number 1, the angle, reference angle, is made up of from these 2 sides, the hypotenuse and the other side beside theta. So the hypotenuse is beside the angle, but so is this other side that is beside. And adjacent simply means beside, okay? It's no magical math term. It's a term we can use in everyday English. We probably don't very frequently, but you could say, you know, Bhupinder is sitting adjacent to Naresh, okay? That just means Bhupinder is sitting beside Naresh. So our hypotenuse, and this side here would be, of course, the adjacent side, okay? And the side across from theta that is not made up, that neither side is making up the actual angle, then this would be the opposite, okay? So if you understand that, and we transfer that over to the second triangle, let's again label our 2 sides that are making up theta. That would be the hypotenuse and this other guy that's beside the angle, right? There's 2 angles beside. One's the hypotenuse, but he's got his own special name, and the other side is the adjacent. Okay? Same triangle, opposite is now adjacent, and the side across from that angle, okay, that is not making up the angle at all, okay, is the opposite. Same exact triangles, different opposite and adjacent labels because the reference angle has changed. It depends on where you're standing in the triangle. So that's key. If you understand this, you probably can figure out everything in trig from here on in, especially this year. All right, so now we need definitions. I guess we want a formal definition. Of course, we can say we know the hypotenuse. That's the easy one, I think. The side across, or we could even say opposite. Okay, it is the side opposite the right angle. Okay, remember the reference angle is never the right angle. Okay, so there's our hypotenuse. And then the adjacent is the side beside the reference angle. That is not the hypotenuse, because the hypotenuse is technically beside that angle as well. So the side beside the reference angle that is not the hypotenuse. And then the opposite side is the side that does not make up the reference angle. Right? It's opposite the reference angle. So let's move on, and I want you guys to try. It says label the sides opposite, adjacent, and hypotenuse. And just to make it easy and quick, let's do O, A, and H in relation to the given angle. Okay, so have a look at the angles. If you want to, circle them, find your reference angle, and just label opposite, adjacent, and hypotenuse for each triangle. Okay, I hope you've taken a minute to label your own triangles. If you have, then maybe pause the video right now and check your answers. Notice down here for F and G and H, we have labeled not just the reference angle, but the reference angle is labeled with the actual angle measurement, okay? And that can happen as well. Of course, we'll get to that in the next page. So let's move on. Trig ratios. The ratios in right triangles have a special name depending on what two sides are forming the ratio. So a ratio is simply a comparison between two values, right? We can write a ratio as 2 to 3, or we could write that ratio as 2/3. Okay, those are different ways to write the same ratio. So in trig, we've got 3 common ratios. So let's look at this question down here, question A to start with. It says determine the sine, cosine, and tangent ratios for the reference angle in each triangle. So here's our reference angle. Okay, and sometimes we call this theta r. Whoops, theta r. Okay, and I write it like this. I write a little circle and then I go bloop, kind of like the Pepsi symbol. Okay, so here's our theta r, our theta reference. And with respect to theta, I need to label that triangle. So let's do so. So I know that my hypotenuse is the guy across from the right angle. The opposite is the side that is not making up the angle at all. Okay, and the adjacent is the side making up the angle that is not the hypotenuse. So of course this is the adjacent. Now if I look at this triangle in particular, there are values given for the opposite, adjacent, and hypotenuse. So if I wanted to find the sine of theta, okay, where am I standing in the triangle? Well, I'm standing right here. This is where I'm standing. I'm standing at the angle theta. And the sine of theta is simply the opposite side divided by the hypotenuse side. I'm just looking up above here. The sine is the opposite over the hypotenuse. So I'm going to say that's 4/5. Cosine of theta would be the adjacent over hypotenuse. And the reason I'm circling at the front or the start letters of each word is because we're going to come up with this little acronym, SOHCAHTOA. And anyone who's taken trig, if you ask your parents, what do you remember about trig? And pretty much everyone, they won't remember how to use it probably, but they'll all remember SOHCAHTOA, okay? Mr. Tully likes to come into my room and say, how's SOHCAHTOA going? Because that's all he remembers from math, because he was a nerdy English teacher. So tan is the opposite over adjacent. So here's the acronym. Sine, S, is O over H, opposite over hypotenuse. Cosine C is A over H, adjacent over hypotenuse. And tan is O over A, opposite over adjacent. So neither of those, or none of those have, it can't be SHO, it's SOH, not SHO. Okay, that's wrong. So it's opposite on top, hypotenuse on the denominator, adjacent on the numerator, hypotenuse on the denominator, and numerator and denominator for OA. Okay, so let's look at the cosine. Cosine, so we can keep this handy. We don't, you'll just go in your test and you would write, if you were in Math 10 in class and I was testing you, or even if you're writing like an assessment, you're going to keep your books open. You're going to write down SOHCAHTOA. Okay, so the cosine ratio is the adjacent over the hypotenuse. Well, the adjacent side is 3, the hypotenuse is 5. Tan of theta, opposite over adjacent, 4 over 3. All right. One thing before we go on, okay? I'm going to relabel this triangle. I can call this side X, and I'm going to call this, angle X. This is angle X, and this is going to be angle Y. Instead of theta, I'm going to call it angle Y. So we've already labeled sine theta, cos theta, tan theta, which would be the same as sine Y, cos Y, tan Y. Okay, same angle, same ratios. If I looked and said, what is the sine of X and the cosine of X and the tan of X? Now what would I do? This is the whole thing, right? We talked about this, is we need to relabel our triangle. So now, I'm going to get out the red pen here. This would no longer be the adjacent. This would no longer be the opposite. Those would change. This would be the opposite, and this would be the adjacent. So if you understand this, this would take us far. Okay, the hypotenuse will stay the same. So sine of X would be 3 over 5. Cosine of X would be 4 over 5. Notice how they've changed. Okay, this was 4 over 5. This is now 3 over 5. This was 3 over 5. It is now 4 over 5. And tan of X would be 3 over 4. So if you understand that, you are well on your way to understanding trig. Okay, let's look at the next one here, I should say. Question B, sine of theta. So where are we standing in our triangle? We're standing right here. This is our reference angle, theta r. Okay, sine of theta. And I always want to say where I'm standing. That tells me that's the angle right there. If I don't know the angle, I put theta. Up here, we knew the angles, so if we knew an angle, we could put the actual degrees in there, but we do not know. So sine of theta, though, let's label our triangle. This is the opposite, the adjacent, and the hypotenuse. Okay, so we got to get good at labeling that triangle. We knowing where we are makes all the difference to the labels. So sine is, let's look at our acronym, SOHCAHTOA. Remember, it's opposite over hypotenuse. It can never be hypotenuse. So here, opposite is 5, hypotenuse is 13. Okay, that's got to be O over H. Not, it can be 5 over 13. 13 over 5 would be so wrong. Mrs. Schwartz would start to cry. So it's got to be opposite over hypotenuse, 5 over 13. You guys get that? I'm sure you do. Okay, cosine of theta is 12 over 13. Right, the adjacent over the hypotenuse, so 12 over 13. And tan of theta, opposite over adjacent, 5 over 12. Okay, and let's do the last question here. Now, it's kind of interesting. Sine of, here's our theta, okay? Theta is right here, so theta, cos of theta, tan of theta. And of course, let's label. This is our opposite, our adjacent, and our hypotenuse. So sine is opposite over hypotenuse. So that's 8 over 16. Cosine adjacent over hypotenuse. So that's 10 over, that's 10 over 16. And the tan of theta is opposite over adjacent. That's 8 over 10. Now, What we can also do here is we can reduce these ratios because 8 over 16 is the same as 1 over 2. Okay? And our 10 over 16 is the same as 5 over 8. And 8 over 10 would be the same as 4 over 5. So as you can see, we can reduce those, okay? And there we have it. Now, why don't we go to the next page and you can do the try, okay? I want you to pause the video and do the try, please. Okay, so hopefully you've had a second or a minute or so to try the try. I just want to go, before we go on and look at the answers here quickly, I just want to remind you or let you know, I don't think I've really spoken of this, but sin, cos, and tan that I hear students say, sin, that's just an abbreviation for sine. Okay, and if you look at your calculator, you will see there is a sine button and a cosine button and a tan button. Okay, but because they can't fit the whole thing on there, we just call them sin, cos, and, but it's sine. Cos is short for cosine, and tan is short for tangent. And it's literally just those Greeks made up the names. They're like, oh, hey, that opposite divided by the hypotenuse, let's call that the sine ratio. And then they said the adjacent divided by hypotenuse, let's call that the cosine ratio. And tangent is, of course, the opposite over the adjacent. So I'm always going to just write that little acronym up, SOHCAHTOA. And when we're looking at this example, hopefully you got this. This was sine of x. So of course we got a little tricked here almost, didn't we, if we weren't careful. The sine of x, well, of course, this is the opposite and this is the adjacent and this is the hypotenuse when we're talking about x. So that was, of course, 8 over 17. Cosine was, of course, adjacent over hypotenuse, which was 15 over 17. And the tan, tan of y, did you guys notice that? We switched it on you. So tan of y, you had to come over here and you had to relabel. This is now the opposite and this is now the adjacent. So opposite and adjacent for tan of y would be 15 over 8. If you put 8 over 15, you got triggered, okay? Because different reference angle, right? So it's always where are you standing in the triangle, okay? So hopefully you didn't get fooled on that one. All right, let's go down to the next question. And I've done a little change here. This first question, it says, evaluate the following ratios to 4 places. And we're going to use our calculator for this. So just take a second. I want you to do 2 things. I want you to change these from sine 20 to sine 30. Okay, cosine 30 and tan 30. 20, 30, it makes a bit of a difference just in ease because I'm going to explain something down here. Okay, I want you to draw this diagram. Okay, so 2 quick things we're going to do. Number 1, I want you to make sure your calculator is in degree mode. Now, how do you do that? If you've got a graphing calculator, I'm going to go to our calculator here, my little downloaded calculator. If you have a graphing calculator, let's clear that. I'm not sure if you can see the screen, but if you go into mode, okay, if you go into mode, this isn't exactly the same as a TI, but it's similar. And you can see down on the 3rd line, I'm going to arrow down using the arrow keys. Now I'm in radian mode, and your calculator, I want to change it to degree mode. So I arrow over to degree and I push enter. And now I'm in degree mode. So I'm going to go out of there. I'm going to show you one more time. If I go into the mode, I can see that my calculator is in degree mode because that is the highlighted word in the 3rd line. Okay. If I wasn't in degree mode, if I go down or rather up here, I would come, if I were in radian mode, I would arrow till I get over to degree. I would push enter, and now I'm in degree mode. I go second function, quit. Okay. If I push sine of 30, I should get 0.5. Now note, if I'm in radian mode, radian is just another way of measuring. You know how we can measure distance in centimeters or millimeters or kilometers or miles? It's the same idea. Instead of measuring an angle in degrees, we can also measure angles in radians or gradians, but we don't use those in grade 10. All we use is degrees. So let's go back to radian mode. And if I go out here and if I push sine of 30, I get weirdness. Oh my goodness, negative 0.988. So that's very strange. Okay, we should never get negatives, so we're not going to worry about that in grade 10. But we do know if I don't get sine of 30 is 0.5, that's a test that tells me whether or not I'm in degree mode or not. So of course I'm going to go back to degree mode. We need to be in degree mode in math 10. One thing to keep in mind is when I do a calculator clear, you know how we go second function plus, and I've taught you how to clear your calculator. I do number 7, reset, reset. Guess what happens? If I go back to mode, I'm back into radian mode. Our calculator defaults to radian mode, so we always have to remember to go back and change it into degree mode. Now, it doesn't matter unless we're touching one of the sine, cosine, or tangent buttons, okay? So let's go back to here. If I push sine of 30, I should get 0.5, or I know I'm in the wrong mode. Now, all this is just a bunch of numbers and acronyms, and what does that really mean? So let's just look at the diagram below. If I have a 30-degree angle and I look at the opposite side and the hypotenuse side, I should get 1/2. So what does that really mean? So that means this opposite length and this hypotenuse length, the opposite should be 1/2 the length of the hypotenuse. Or in other words, let's just say that this length here were 5, okay? If my opposite side away from the 30 is 5, then the hypotenuse side would have to be 10, because that ratio is of 5 over 10 has to equal to 1/2. Okay? The hypotenuse is twice the distance of the opposite. If I were to, in fact, let's take, I'm just going to move this out of here for a second. Okay? If I were to, in fact, take and double the length of the hypotenuse, let's double the length of the hypotenuse. Let's, in fact, make that, instead of 10, let's make that now, the whole hypotenuse is 20. Okay? If this is 20, we're doubling the whole side of all the triangle. Okay? And I go down here. And now if this whole length here were 20, then this opposite length here would have to be 10. But the ratio is still, 10 over 20 is still 1 over 2 or 0.5. So that ratio can be a decimal, a fraction, etc. So hopefully that kind of makes sense. Okay, no matter what, and that's like a truth. Every single angle ratio is programmed into your calculator. When I was a kid, we didn't have graphing calculators or scientific calculators, believe it or not. We did have calculators. I'm not from the dinosaur era, but just slightly after that. And we had to look up all of our angles in tables. So now it's all programmed into our calculator because it's the truth. Every right angle triangle with an angle of 30 degrees has to have an opposite side that is half the distance of the hypotenuse. That's how it goes. And of course, if I plug into my calculator the cosine of 30, if we do cosine of 30, I'm just going to plug that in, cosine of 30, I will get 0.866. Oh, and this says to do to 4 decimal places. So if it says to round to 4 decimal places, by the way, we should technically have 4 more zeros, or 3 zeros, right? 4 decimal places. So this is 0.8660. That's the cosine of 30. That means that this adjacent side here would be, if this were let's just do this for a second. If this, for easy numbers, okay? If my hypotenuse were 1, this would be 0.8660. So my adjacent over my hypotenuse, okay, cosine of 30 would be 0.866 over 1. Okay, it's a decimal. It's just how it works. The sign is a nice number. It's a half. The cosine happens to be that this adjacent side has to be 0.866 to 1. Okay, the tan ratio here would be tan of 30, 0.5774. Okay, because it was 3, 5. So we round up. Okay, so we plug these into our calculator. This tells us the ratio because they're all programmed in. Sine of 33, 0.5446. Cosine 62. It's just that easy. Okay, 0.4695 because that was 47. Okay, we round up, right? We're going to round up because of the 7. And then tan of 27, I push tan 27, 0.5095. Clearly, you need a calculator to do trig. You don't need a graphing calculator. Some students, and you can even use your phone calculator. I wouldn't advise it. It's very complicated to use your phone calculator for trig. But you do need to go into your calculator and make sure you are getting the same ratios as me. Because if you are not and you don't understand how to use your calculator, you will be at a loss. So tan of 27, 0.5095. Let's take a turn, and I want you guys to try. You go ahead and try. So pause the video. And just to keep you guys on your toes, I'm going to give you the password here. And what should we make the password this week? How about excellent? All right, now hopefully you got the same answers as I did. If by chance you are struggling at all with your calculator, contact me immediately, if not sooner, and I can help you out with that, okay? I can figure out what kind of calculator you have, or whatever, okay? If we were in class, there would be always a few students who maybe needed to get shown how to use their calculator. So make sure you contact me right away if you're not getting these answers. Now, likewise, our calculator is programmed with the ratios, with the given angles, and if therefore we know the ratio, then our calculator can give us the corresponding angle. Okay, so for example, the angle, right, this is always the angle, right? Theta is the angle, or in this case we're using x, we could have used theta here, okay? Sine of x is 0.333333. That's our, right, that's 1/3, okay? 1/3 is 0.3333. So if we know that sine of theta, okay, or sine of x, let's just kind of think and visualize what this means, okay? If sine of x, there's our angle x, which we could have called theta, is 1/3, our opposite over our hypotenuse, then our calculator would know that if our ratio is 1/3, or 1/3, or 0.3333, then we will be able to find our angle. What is that angle? Well, how to find that is we've given the ratio, we want to go backwards to find the angle, and we call that the inverse sign. It's the inverse, the opposite of the trig ratio, the inverse of the trig ratio. So how to plug that into our calculator, we just do this. We use the inverse sine of 0.3333, and we plug that in, and what do we get? Second function sine. So you're going to have to use the second function or shift key or whatever your calculator has, okay? Second function of 0.3333, and close that bracket if you've got a bracket, and we get an answer here of, let's go fill that in. Our answer here is 19. It says round to the nearest degree, so that's whole number, the nearest whole number, okay? The nearest full degree. So it's 19.469, which is 19 degrees, right? 19.469. Okay, we round here, that's a 4, so that just stays as 19. Okay, so we want to try to make sure we're rounding properly. All right, the next one, cos of 0.33333, cos of the angle, right? So what is our angle? Our angle is the inverse cos of 0.3333, and we're going to plug that in our calculator. Second function cosine of 0.3333, and we get 70.5 or 71 degrees. Okay, inverse tan, or the second function, whoops, why am I writing cos? Second function tan of 0.3333, and of course we get 18.4, 18 degrees. All right, now sometimes our angle, okay, theta, or our angle, can be a fraction. So to find this, we're going to say inverse sine. And why am I using sine? Because it was the sine ratio. Okay, I don't use cosine because we're using sine. Inverse sine of 2 divided by 3, we can enter a fraction in our calculator. Okay, so second function sine of 2 divided by 3 should be 41.8, which we're going to round to 42 degrees, right? 41.8 rounds up to 42 degrees. And the last one, second cos of 5 divided by 7 is 44 degrees, 44.4. Okay, so there's our answers there. If you want to pause the video and give it a try for the last couple, that would be awesome. Okay, and hopefully you had a minute to check these answers. You can double check that you got the same answers as I did. And for your assignment, I would give you numbers 1 to 4, just A and B. Okay, if you want to do all of them, you can. 5 to 7, you can do the odd letters. Okay, for those, mostly calculator stuff for those ones, just quick. And then number 8 and 9 are a couple of just quick comprehension questions. So get those done. If you have any questions, give me shoot me an email. You should do great this week. This is a fast lesson, and hopefully Trig makes pretty good sense to you. Once you go through it, it's usually one of the students' best and easiest units. Okay, good luck and keep in touch. Thank you.